Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI MStat, and CMI MSC Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISIM Stat, and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
Any more suggestions or kind of opinions on how to proceed? Okay, the next question is, how will you kind of, I hope you are not minding. I'm just kind of making it a bit interactive so that it's fun. So any other opinions how to use the exclusion inclusion principle here? Say, let's take the base case. Say there
It's me.
yeah, what question do you have? This favorite was.
Actually, I was like proceeding in such a way that let us take at least one envelope and write correct, and then at least two, and then at least three. Likewise, in at least n.
Right. So what you want to say is
We will make a summation of at least one letter is incorrect envelope. And
so
then
you want to
at
say
least two, at least
the
three,
next
like that.
the next opinion is total minus something, right?
Yes.
Total minus like what? At least one.
Summation of at least one and at least two, at least three, at least n.
So all of them will be minus, or
Yeah.
all of them will be minus, right?
Yes.
So the problem here is, I don't know if if you can see this. If you consider at least one, this is already a part of this, right? Or maybe the other way around, right? You're getting me.
What if we remove the at least word? Like one letter is in correct envelope, two letters are in correct envelope, three letters are in correct envelope. Likewise, n letters are in correct envelope. We will get a
Alright,
general formula, I think.
so the next opinion is one minus one. Like what? Total minus
One letter is
one letter in one envelope. Then again a minus.
two letters in correct envelope.
Two in
Likewise,
two in
n
two
letters
envelope.
in n letters in n correct envelope.
We can implement. Of course, let's see. Say we have. Should we take n equals 2? Sorry, not this. Yeah, of course you're correct. You're going to the correct way, but I want to implement the exclusion equation. So if I want to implement, if this is the way, should there have been a plus here or something like that? Because are we double counting? We need to think. So total minus one letter in one envelope. What do you mean by one letter? What do you mean by one letter in one envelope?
Correct envelope. One letter in correct envelope. So we will get an NC1 into
Right.
n minus 1 factorials.
Right. Okay. So this is your claim. Right.
We are choosing a envelope and putting the right letter, and the rest we are distributing in other envelopes.
Let's see. So there are like you have L1, L2, and L3. and you have envelope 1, envelope 2, and envelope 3. Say total will be like n factorial, right? First of all, there. Now you want to
Let us.
say one letter in one envelope. So say for example, 2 goes to 2,
Uh,
right? 2
right.
goes to 2.
We are
Then
stuck
1 goes to
still.
3 and 3 goes to 1. This is one of the cases.
This can be one of the cases, but what if letter one goes to envelope one? We are still stuck.
Right. So this is one of the cases, and the second case will be sorry, L1, L2, and L3, envelope 1, envelope 2, envelope 3. 1. So initially 2 used to go to a E2. Now
E2.
I want to fix 1, the first permutation. I mean the first element.
Okay.
L1 goes to 2. Similarly, in the third case, I will fix L3. So I don't know what there will be here, but I do know that whatever there will be here, there will be 3C1 number of them, right?
Right.
Because once I want to fix L2, then L1, and then L3. But then all of these cases are kind of symmetrical to each other. So whatever there will be in here have to be equal. I mean, that's not how I will prove it mathematically, but it's easy to observe, isn't it?
Yes.
Right? Now, how many of them will be here in each of them?
We have to eliminate all the cases, right? In which there is at least one and letter in the right envelope, right?
Yeah.
Uh,
Yeah, I mean, you can discuss among yourselves. Fine. Go ahead.
So
but
it can be yes. Say,
Yeah.
Vipul.
I think we are going wrong because the rest of the arrangements will also like when we choose the first case, letter 2 goes in envelope 2. With that, we have two cases. Either letter 1 goes to envelope 3 or letter 3 goes to envelope 1.
Right.
Actually,
And
I have a kind of solution.
Yeah, please go ahead.
go ahead.
Suppose that there are 3 letters and 3 envelopes.
Mm-hmm.
So the total number of ways will be 3 factorial.
Mm-hmm.
And
So
I
yeah,
should subtract n minus 1 envelopes in the wrong order. That will be 3 factorial minus at least 2, means 3C2. And
3 factorial minus 3C2. Okay.
and the last one is the all are correct, means minus 1.
Minus 1.
This is the
So
answer.
what can you say why this is 3C2?
This is because this is the case when there are at least n minus 1 cases in which the envelope is in the correct order. The Deepak is saying that it should be like at least 1 minus at least 2 and all of the summations will be going on. But here is the catch. We can assume it we can say it like at least n minus 1 will contain all that, at least 1, at least 2. So I don't have to subtract all of that. That's my thing.
Okay. Okay, fine. So the total is n factorial. Fine. Then I'm subtracting 3C1 because I will have this three of them. 3 cases of looks something like this, right? But now these 3 cases are kind of symmetrical to each other. I fix one of these envelopes and it goes a crisscross. I fix one of this and goes a crisscross. It's fixed. The total is fixed. All of them are symmetrical. So whatever number appears here, I'll be multiplying with 3C1. The number is something kind of a fixed number, right? And how many of them will be here? What should I replace here with this?
I think it's
You were saying a number.
factorial.
Exactly, it's 2 factorial because for L1 I have 2 choices, and if I fix L1, I'll have 1 choice left for L3.
But we are still going wrong. Like L1, we have two choices. Either it is envelope 1 or envelope 3 for letter 1.
Mm-hmm.
What in case of L1 goes in envelope 1? That will be in correct order. And
Exactly. I'll come back to that. I'll come back to it. This is what I'm saying. I'm just trying to kind of, see why this particular option is not the right approach. This is what I'm kind of trying to discuss it. I see your catch. So I'll subtract what? I mean, oh wait, this is not n. This is 3 factorial. So there will be 2 of them because L1 has 2 choices. L3 has 1 choice. And then according to you, I'll subtract 3C2. How many ways can you arrange? And there'll be something here, the multiplying. So this is what you want to say.
yes.
But the problem here is this way could be a bit of a misleading because so okay, this particular way is accounts for these ways, right? Now when I come to this particular way, there is something you are kind of double counting. I'll show you why. Say, so what does this particular element mean? It means 2 envelopes are in correct place, right? 2 envelopes are in correct place. I can put L1 without loss of generality. Okay. It means that the rest of the cases are similar. So that's why I'm not doing that. So L1 is in L1, L2 is in L2, and L3 is in L3. I have no choice. That's what you're saying, right? So don't you think this case already appears here?
Yes.
In one of the cases, it appears here, right? L1 is in L1, E1, but L2 had 2 choices, either E2 or E3. If I move it to the E3, I am right. But what if I move L2 to L2? Because this is one of the choices. That's why I'm multiplying it by 2. L2 had 2 choices. That's why I'm multiplying by 2. So I'm multiplying by 2 into 1. More or less, why does this 2 come? It comes because L1 goes to E1 and L2 had 2 choices and then L3 had 1 choice left because one of the envelopes would go to L2. So you are kind of double counting it. So I mean, it's fantastic. I mean, you are going in the right direction. You also found out that we are indeed double counting, but how do you account for this double counting?